This meeting is being recorded.
In this last video from chapter 19 on electrochemistry, we're going to take a look at sample exercise 13. This is another example that allows us to do this quantitative calculation using electrolysis. So we're told that we're given this half reaction for the formation of magnesium metal upon electrolysis. So we pass current through magnesium chloride and we generate this reaction here. So we have Mg2 plus that will be reduced using 2 electrons, and then we get this magnesium solid. So this will be the equation that we use to know that we have 2 moles of electrons that are being passed through or being transferred rather in this reaction. So in part A here, we're asked to calculate the mass of magnesium formed if we pass a current through of 60 amps for a period of 4 times 10 to the third seconds. So that's 4,000 seconds. So I can either go from time to mass or mass to time. So in this case, I'm going to start with my my time and my current to generate, or rather, yeah, my current to generate how many coulombs. So if we took 4,000 seconds and we multiply that by 60.0 coulombs per second, we're going to see that that's really 4,000 times 60, or 2.4 times 10 to the fifth coulombs. So we're going to start there. And we're going to use our first conversion factor that we know is the Faraday's constant. For every 1 mole of electrons, we're utilizing this 485 coulombs. Our next conversion factor, now we need moles of electrons. So that's from our balanced equation. We know that 2 moles of electrons, let's take that back here. We know that rather for every 1 mole of our Mg2 plus, we're moving 2 moles of electrons. So that's where our moles of electrons will cancel. 1 mole of magnesium on top, and we know last we're going to need our molar mass, which is approximately 24.3 grams per mole. So now that we have everything canceling out, we have our coulombs, moles of electrons, and moles of magnesium will also cancel. We're going to be left with grams at our end here. So I will take this 2.4 times 10 to the fifth, divide by Faraday's constant, divide by 2, and then multiply by 24.3, and you should get around 30.2 grams of magnesium for part A. So now in part B, we're going to see how long we're going to solve for time if we're given our target amount of 50 grams of magnesium. So we're going to use the same half reaction. We're going to change the current now. So we would know if the current was 60 that it would take 4,000 seconds for 30 grams. But now we're going to change the current around, so we can't just do a ratio. So we're going to start with what we're given, the 50.0 grams of magnesium. Now we're going to work kind of backwards here. We're going to say for every 1 mole of magnesium, my molar mass is 24.3 grams. All right, so now I'm in moles of magnesium. So here's where I set up this relationship. For every 1 mole of magnesium, we're going to need 2 moles of electrons. Now I'm going to be multiplying by the Faraday constant, 96,485 coulombs. So now I'm in a unit of coulomb. I just need to get to time in seconds. So now if I divide by 100 coulombs per 1 second, remember this is my relationship to amperes. I just have to flip my conversion factor now. Coulombs will cancel, and I'm going to end up with a unit of time in seconds. So now let's go back. We're going to multiply 50 by 2 by 96,485. Then we're going to divide by 24 and then by 100. And we should get approximately 3.97 times 10 to the third seconds.